Good morning, everyone. We got a lot of people in here today. Well, let's get down to business. We are going to continue what we were doing last class, which is working with proportions. We're going to do a few word problems. After we do that, we're going to move on to percentages. And then after percentages, we're going to do some word problems with percentages. So that's kind of what's on the slate for today. And then next week, we'll only be meeting on Tuesday, right? Because Thursday is Thanksgiving. So, and then we come back, have, I believe, 1 week, and that's it, then finals. So let's get down to business. The main idea here from last time is that if you're given a relationship between two things, like the problem that I gave you for homework, right? If you're given some relationship, like Robert can type 40 words in 32 seconds, right? The important aspect here is that what that means is you can turn that into one of two things. You can turn it into a ratio where you write 40 words over 32 seconds, or you can write it as 32 seconds over 42 words. Okay, so this statement that 40 words in 32 seconds is equivalent to both of these ratios. And then if you're trying to solve for something like the first question here, part A, if it says how long will it take for him to type 1,246 words, you look at what you're trying to solve for. So in this case, we're looking for how long, right? So that's time. And so once you've determined what you're trying to solve for, that will dictate which of these two you're going to use. And so since we're trying to solve for time, we will use the one that has time on the top. All right, if we were trying to solve for the words, like in the second one, how many words, then we would choose the ratio that has words on top. So that's the main idea here. You're given some information, you create two ratios, then you go try and see what you're looking for, and then whatever you're looking for, make sure you use the ratio that has that on top. All right. So let's do some problems, some more of these problems. Let's see, where is it? Here we go. So I'm going to work through these. So Joe's heart beats 11 times in 10 seconds. At that rate, how many times does his heart beat in 60 seconds? So we talked a little bit about this last time, that you could do this without doing any ratios. If you just kind of like look at it and things work out. I mean, 10 seconds, 11 beats in 10 seconds. So 60 seconds is 6 times as much as that. So your answer should be 66. That's all great if you can do it, if it's easy like that. What I need you to do is show me the ratios and solve the equation, because sometimes it's not that easy. Sometimes we have decimals and it's not as easy for us to just say, oh, just multiply by 6. So let's work this one out. We've got 11 beats, right, in 10 seconds. So I'm going to create two ratios. I'm going to put 11 beats over 10 seconds. That's one of them, or I can use the 10 seconds over the 11 beats. Those are equivalent. So I just have to choose which one I want. So it says here, at that rate, how many times does his heart beat, right? So we want to know how many beats we have in 60 seconds. So since we want to know how many beats there are, right, that means we're going to use this fraction. So now I set up the proportion. So using the fact that I'm looking for X, right? X beats is what I'm looking for over, and now the time that I'm given, 60 seconds, that should be proportional to this ratio here, 11 beats in 10 seconds. And then what I told you, once you get this set up, you can do cross multiplication. So you can multiply the 10 times x and the 60 times 11. So if I do 10 times x, I get 10x. And if I do 60 times 11, I get what? 660, right?
Yeah, that's what I got.
Okay, and then now just solve for x. So divide by 10 on both sides, and you get x equals 66. So look, on the final exam, all right, which is going to be in what, 2 weeks or so? On that final, wait, it's not 2 weeks, 3 weeks. I want to see this work, okay? I don't want you to just put, oh, 66, all right? Because then it completely defeats the purpose, because I could very easily give you a problem where you can't do it in your head that easily. I'm not trying to make it harder though. So just show me you understand the procedure of the process, all right? Let's look at the next one. One plain bagel has 320 calories. How many calories are in 2.5 bagels? So I'm looking for calories, right? That's what I'm looking for, calories. So I can set up two proportions, two ratios. Can someone tell me what the two ratios, what's one of the two ratios I can set up here?
One bagel over 320 calories.
One bagel over 320 calories. Okay, someone else tell me the other one. I'm just gonna put cal.
320 calories over one bagel.
Calories over one bagel, right? Okay, now which of the two are we going to use? One bagel. Well, we're looking for
The
calories,
second
right?
one.
Yeah, so we use the second one because we're looking for calories. The second one has calories on top. And so we're going to use this one. So now we set up the proportion, the number of calories, X, over the number of bagels, 2.5. So when you do 2.5, I would use 2.5. I would use a decimal. So this is how many calories over this many bagels should be proportional to 300 calories over one bagel. And then you cross multiply. Okay, so you multiply 1 times x, 1x equals 2.5 times 320. So what is that? 640, 7, what is that? 7, 8?
800.
800 even. So that we don't have to divide through by 1. So our answer, oh, you know what? I forgot to do on my first one. Sorry, I forgot to put the units. Your answer, you need to put what this is, 66 what? And remember, we were solving for beats. So put beats here. And then here it would be 800 calories. Because we were solving for calories. Understand? We'll do this last one. You know what, by the way, off topic, but kind of on topic. Do y'all know what a calorie is? Does anyone know what a calorie is? I mean, I know we all have heard the word, but do y'all know what it is? What it's a measurement of?
It's a measurement of the energy and the amount of energy that's in food.
Yeah, so like we have to eat food, right? In order to live, and our body takes that food, processes it, right? Metabolizes it and digests it, right? And it converts that into energy, right? So the technical definition of a calorie, since it's energy, and energy is actually heat. Heat is what energy is. So a true calorie is this. If you take one little, imagine you have a little cube and you fill this cube with water. Okay, so there's water in this cube and it's 1 centimeter by 1 centimeter by 1 centimeter. So it's this little small little cube, 1 centimeter by 1 centimeter by 1 centimeter. Take that and imagine that little piece of water. And then take a flame, okay, and here's a flame. That's a really good flame, right? Here's a little candle. So here's a candle. This is energy. Okay, 1 calorie is how much energy it takes to take this water and increase the temperature by 1 degree. That's what 1 calorie is. It's the amount of energy required to raise the temperature of this little piece of water by 1 degree. So when you consume calories, it's actually just, it's a weird way of measuring the amount of heat it's going to require to like break that down. That's why we have temperature. That's why our bodies have a temperature, right? 98.6. It's energy, that's heat, right? Okay, that's just a random useless thing. If you've ever wanted to know what a calorie is, it's actually a measurement of heat needed to raise the temperature of water by 1 degree. It's kind of weird. Okay, now let's do this one, a leaking pipe. So a leaking pipe, this particular leaking pipe they're talking about, okay, can lose 24.7 gallons of water in 1 week. How many gallons are lost in 30 days? All right, so we have first what's given to us, right? 24.7 gallons in 1 week. So I have 2 ratios I can set up. 24.7 gallons. I'm just going to put G over 1 week. Or I could use 1 week over 24.7 gallons.
Shouldn't
right.
you put it as 7 days, since we're trying to find how many gallons are lost in 30 days? Not
Yeah,
weeks.
so yeah, I was about to get to that. So look, everyone, what are we looking for? How many gallons, right? That's what we want to know, how many gallons. So that already tells us we're going to use the first one, right? We don't need this one. But it says how many gallons are lost in 30 days. And that, so we have a problem here because our ratio has gallons and weeks together, and we want to know how much is lost in 30 days, not 30 weeks, which means we need to do one of 2 things. We need to either convert days over to weeks, or we need to convert weeks over to days. So what's easier? What's easier to do? Is it easier to tell me how many days are in a week, or is it easier to tell me how many weeks are in 30 days? I think most the days, right? Let's convert the weeks to days. So I'm going to take this, and instead of doing this, I'm going to say 24.7 gallons in 7 days. And that's the conversion. That's the ratio I'm going to use to set up the proportion. So be careful with that. When you read the problem, make sure you're paying attention to those little details. All right. So now I come over here and I say, all right, I have X gallons in 30 days. And that must be proportional to 24.7 gallons in 7 days. And then I cross multiply. So 7 times X, 7X. And then this is what I was saying. You can't really do this one easily in your head. You're probably gonna need a calculator for this. So I do 24.7 times 30, I get 741. And then I divide both sides by 7. And I get 105.86. I'm rounding. And then this is gallons because we want to know how many gallons. So I'm going to put gallons. Okay, there we go. 105 gallons were lost in 30 days with this leaking pipe. True story here. Right after COVID hit, it was right. I think it was April. Was it April of 2019? Is that when things really started? They started to lock everything down right after spring break. I woke up to get ready to go to work at 6 a.m. and stepped out of my bed into about 1.5 inches, 2 inches of water, and completely freaked out because you don't expect to step into water. And pretty much our entire first floor of our house was completely flooded. And it was a leaking, it was you know, the hose that comes out of the wall that goes to your toilet, that hose ruptured in the middle of the night. And we didn't hear it. We had dogs. They didn't do it. The dogs were just up on their little doggy bed. Like they didn't care. They bark at everything. They didn't bark at the waters. So these dogs are ridiculous. But anyway, so yeah, so this little hose, it was a tiny little hole in this hose and it was leaking for maybe 7 hours that we know of, about 7 hours. And I estimated that we lost probably about 3,000 gallons in 7 hours. So yeah, this pipe's just barely leaking. To lose 100 gallons in about a month. Yeah, that would have been nice if that would have been what happened to us. But anyways, all right. So do y'all understand these? The procedure, you look at the ratio, you set up your two ratios, you go look for what you're looking for, pick the right ratio, set up your proportion, cross multiply, pay attention to the units, make sure everything's measured the same. Like on this first one, if it said 11 times in 10 seconds, I could have said, how many times does his heart beat in 6 minutes, right? And then you would have been like, ah, wait, hold on. One is in seconds, one is in minutes. So you'd have to convert, you'd have to change one of them. So just pay attention to that. Questions? Okay, now we're going to talk about percentages. And we talked a little bit about percentage last time. We kind of know what they are. But now what we want to do is we want to use what we know about percentages to solve some, these aren't word problems. I mean, they are, but these aren't like the type of word problems you're going to need to be able to do on the test. These are problems that will help us solve the word problem. So these are just like little statements. And what we want to do is be able to read this statement and take it and create an equation to solve. So let's just look at this first one. So look at the instructions, because this again, on the final, people get points taken off because they don't do this part. Write each of the following as equations. So we first have to write this as an equation, and then we will solve it. So I'm not looking for just a solution. I'm looking for you to write it as an equation first. So when we're looking at this statement, this statement here, there's some keywords we want to look for, all right? Anytime you see the word is, that normally means an equal sign, all right? If you see the word what, that's the thing you're looking for, and so we will let that be X, or a variable, okay? That's not a multiplication sign, that's the letter X. If you see the word of, that usually means multiply, which I'll just use a dot for multiplication. All right, let's start with that and see if we can translate this word problem, or this statement, into an equation. So I look at here, it says, okay, what is what I'm looking for? So what is 35% of 200? What is X? Right? Is our equals. So X is, now 35% is a percentage, but we talked last class about when you have a percentage, you can convert it to a decimal. So anytime you write the equation, you will need to convert this into the decimal. So we know that as a decimal is 0.35, right? Oops, 0.35. Just move the decimal 2 places to the left. So this is 0.35. And then the of is multiplication, so times 200. And that's it. We just want to know, now we just want to solve this equation. So here's the first part, I just write the equation down. Now the second part is to solve for X, but there's nothing to do here to solve. X is already over here. We just have to take this and multiply this on our calculator. 0.35 times 200, and I get 70. Okay. Why don't you take a second, take a minute, see if you can set this up. See if you can get the equation. All right, does anyone want to tell me did anyone get the answer?
I didn't go that far, but I got 200x equals 35.
Okay, so let me see how you got that. So you turned this 35, just left as 35, then what did you have after that?
Is would be equals,
Okay,
and then what is x? And then of is times, so be times 200 or 200x.
yep, okay, good. So 35 equals 200x. Now, what this x here, when you say what, it's actually what percent, right? That's what so if you're confused, like, what do I do with the percent? That's part of what you're looking for. You're saying what percent of 200? Okay, good. Now, how would we solve for x here? We're gonna get x by itself.
Divide.
Divide, right? Okay. So now we'll need our calculators. 35 divided by 200. I just looked at the chat. That's funny, Dylan. Okay, let's see. We got 0.175 equals x. Now, that is correct, but it doesn't answer the question. The question says what percent, right? So we need to take this answer and do one more thing, convert it to a percentage. And that means move the decimal point over to the right 2 places. If we do that, we get 17.5%. Why don't you try, yeah, I'm gonna let you work these. See if you can do these 3 problems on your own. Just remember, all percentages need to go to decimals if you're setting up the equation. And then also, if you're solving for a percent, at the end, you have to convert it to a percent, just like we did. See how it goes. I'm gonna put up a poll, and don't do anything on the poll yet. When you finish all 3, just click choice 1 when you're done with all 3 of them. Okay, we still have people working. I'm going to start writing out the equations and solving these. And that way you can check your answers.
I have a question.
Yes, go ahead.
So I was taught a different way and I just want to ask in case like it won't always work for me.
Uh-huh.
So I was taught to kind of set it up as a ratio over like, well, I'll just say it for the first one. So like for number 5, it would be 40 over 100 equals 25 over X.
Hmm.
And then
That's how
I
I was
would-
taught as well.
yeah, like I multiplied 100 by 25 and then divide by 40. And I got the same
Okay, so-
answer
so-
as if I did it the way that you just set it up.
Okay, so let me just make sure I understand this. You were taught to, you rewrite the 40% as 40 over 100,
Yes.
and you set it up as a proportion, and you say 25 over X?
X,
That-
yes.
Okay. Now, what I'm trying to get at, okay, then how would you do number 15 then?
Number 50, or you mean the
I mean,
next
sorry,
one?
number 6, sorry.
Oh, number
six.
6, I did 15 over 100 equals 19.5 over X over,
Okay. All right. And then what about the last one?
the last one. I didn't get to the last one.
Okay,
And then
So-
that second one,
Being taught, I was taught how to do it the same way. I would have written the last one as 15 over 100 is equal to 35 over X.
so yeah, the last one I'm trying to figure out how you would do that one. You said you would do it how?
15 over 100 is equal to 35 over X.
So can you tell me, like, this is not wrong, okay, but I'm trying to see, how would you teach someone to do it that way? Like, what do you tell them to do? Like, if you're reading this equation, what are you telling them to do?
so percentage is like out of 100.
Okay, so good. So you turn that into that. Okay, now what?
Mhm. And then that would equal that 19.5 is going to be 15% of some number.
Okay. So how would you have done the first one then?
The first one,
The first one,
Hold on, let Doralee continue, because
Sorry.
I want to hear her explanation going off of what she just said.
so
So
the
how
first
would you
one was 35 over 200 equals X over 100.
35 over 200?
And I got the same answer there, but I might have, now I'm seeing that I might have done that one wrong. But I got the same answer as you somehow.
Okay, so hold on. You did 35 over 200 and then over or equals what?
Or no,
Okay.
yeah, I think I did. So 35 over 200 equals X over 100.
Okay, and then now, Nix, how would you do number 3?
for number 3, I did it 35 over 100 equals X over 200.
Yeah, I think she's right. I did that one wrong.
Well, I'm not.
No,
so-
but that hers makes more sense. I just set it up wrong for that one.
But I'm still trying to understand, how would you teach someone to do that? So like right here, this problem right here is very different than like number 5. So how are you, I'm not saying it's wrong. I'm just trying to see, like, if it works, it works, but how would you explain it to somebody what you're doing? Because I can follow you saying, okay, take the 40%, turn it into 40 over 100, but why am I doing the 25 over X? Why am I doing that here? And then up here, why am I doing X over 100 instead of 100 over, or why am I doing X over 200 instead of 200 over X? Because over here, you understand what I'm saying? Like,
How it was taught to me was that for the first part, when you're taking the actual percent that you're given, you take the percent and you put it over 100 because a percent is always out of 100.
Yep,
Then for
okay,
the second part, if you're finding, like in number 3, if you're finding what is 35% of 200, then that means it goes on the bottom. But if you have, say, like number 4, where it's asking 35 is, what percent is 35 of 200, then it goes on the top.
okay, so I will agree with that, okay? But my perspective, just going and taking my brain back to when I was learning this, to me, that's confusing. To me, that's confusing, like these different scenarios, just to me, right? I mean, if you're happy with it, if it works and you get the right answer, I don't care what method you've learned in the past, if you're happy with it, stick with it. But I'm not going to teach that method only because to me, it's like you have these different cases. Like if it's of this, then you do that. And if it's
okay.
what's on this side, then you do this. It's like these different cases. What I'm showing you is just write the equation, solve the equation. That's it.
I was taught the same way. That's why I never understood percentages. It was always
Yeah.
confusing.
Yeah. If you can always just write down the equation, figure out where X is, then it's just algebra, move things around, divide, whatever it may be. But it's just getting the equation set up first is the most important thing. So look, I always say, like, if a student is comfortable with a certain, like factoring, if you know how to factor, I'm not going to try and reteach you how to factor. But anytime I'm trying to present something, I'm always trying to present it in the way that makes the most sense to me. But we're all human, we think differently. You may like the method where you have to look at the different scenarios. That may just make more sense to you. So stick with what works for you. I'm going to stick with this. Hopefully, majority of the class will be okay with it. Yeah. So,
Okay,
but
I
I'm
was
glad you
just
brought it up.
asking, sorry.
I will accept it. I will
Okay,
accept it. Okay. Now, if it's wrong, it's wrong, right? Okay.
no,
So
I know.
if you do it and you do it the way you've learned it and it's not working, then that's okay.
Okay,
So I think what you're asking me is can you write your equation this way as opposed to this way, right?
yes,
And they are the same equations. They don't look the same, but they are the same equations because what are you going to, to solve this, you're going to cross multiply, right?
yes,
And then you're going to wind up with
Dividing.
X on one side, and it's the same exact equation, just rewritten. That's all, so yeah, I'm okay with that.
okay, thank you.
No problem. I'm glad you asked.
I do definitely remember that when we were going over percentages in my classes, that most people were confused. It just
Yeah.
happened to click with me because I was really good at proportions.
Yeah.
And
Yeah, I
so
mean,
it made
really,
sense for me.
you don't need the equation if you understand what the proportion is. But the problem with that is it all depends on where what you're looking for appears in the sentence. Like if it's, yeah, see, I don't want to get into that. So, all right, good. So this first, the 3 I asked you to do are here. So here was the first equation, 25 equals 0.4 of times X. The second equation, let's set them all up first. The second one, I'm going to take this, convert it, 0.15. Of is multiplication of what? Well, of some number, right? We don't know what that is. So let's call that X. So that's the first time we didn't have the word what in there, but it's implied in the sentence that we're looking for a number, right? What are we looking for? We're looking for the number. And then it is equals 19.5. And then the last equation is 35, right? 35 is 15%. So we need to understand that that's actually 15%. And I convert that to a decimal, 0.15. And then of, right? Of is our multiplication. What value is our X? Are there any questions on those 3 equations being set up like that? Does that make sense to everyone? Good. All right, let's do the first one. To get X by itself, divide both sides by 0.4 or 0.40, and we'll have an answer. 25 divided by 0.4, yeah, 62.5 is X. All right, on the next one, we're gonna divide both sides by 0.15 to get x by itself. $130. And then the last one, divide both sides by 0.15 again. And we get 233.3, and the 3 repeats forever, but you could round it to just 233.3. That's fine. You don't have to put the little bar on top of the 3. Okay. We good?
I have a question.
Yes.
So for those, I kept, whenever I set up the equation, I kept the percent as a percent and then moved the decimal from my answer to get the whole number. Is that okay, or should I move it directly as a decimal in the equation? Because I still got all the same answers. I just
Yeah,
don't-
so what you did is you left the number as a 15, right?
Yes,
And then at the end, whatever answer you got, you move the decimal. Is that what you
Yeah.
did?
yes,
So yeah, you'll get the right answer. I'm just afraid you're going to forget to move the decimal. That's my only concern, is that you'll forget to move it.
okay,
Or it'll be like on number 30, look at number 4. On number 4, right, we're solving for a percent. So you might, I don't know, you might forget to move it. So you'll get the right answer, but you have to, you'll get the right answer as long as you remember at the end to move the decimal.
okay,
So that's why I say, anytime you're doing these problems, anytime you see a percentage, anytime, right?
Mhm.
Just right off the bat, go ahead and
Do a decimal.
convert it to a decimal.
okay.
And then you don't have to worry about it again.
But
The
then-
only time you ever have to worry about converting or moving your decimal again is if you're solving for a percent.
Okay.
You just have to remember at the very end, take that back to a percentage.
Okay, ready, thank
Okay.
you.
Yep. Okay, that was good. That was a good discussion, because it is weird when I look at people's work and I see what they do, like things like this, I'm like, what are they doing? You know, like, and I realize it's because you've seen it a different way, but it's good to actually talk to you and hear like what you were taught, because I don't understand that teaching it that way. Like, it doesn't make sense to me, but it's okay. It's fine. To each their own. But you know what? That's actually a deeper conversation. I think that's part of what makes math challenging to learn, is that when you're being taught, there's not like one way to do everything, right? Like, so, you know, when I teach, like, especially in the like calculus, right? When I teach the calculus classes, I always teach it the way it makes sense to me, but that may appear different than the way another person sees it. So when they teach it, it looks different. So you wind up getting like, you know, all these different like variations of the way people learn math, which is challenging. All right, here we go. Now, these problems are going to be word problems, and they are going to have a mixture of kind of like all these ideas of proportion and percent together. Let's just see how this goes. Now, I will tell you, this is not a problem where you just set up an equation, okay? This is not where you just set up the equation, read it, you know, turn the what into X and is into equals. It's not that simple. We have to actually read this and understand it. So 30% of all students at Northwest Vista transfer to UTSA. Of these transfer students, 12% are going to major in biology. If there are 15,435 students at Northwest Vista, how many will transfer to UTSA and major in biology? Okay. So when you read that, I realize this is confusing. So here's what I like to do whenever I have something confusing, is I like to draw pictures, right? If I can. So I'm going to draw a picture here. Let's say that this is all the students at NVC. Okay, that's all of them. And how many of them are there? Does it say in here how many students are at Northwest Vista?
15,000.
We have
435.
15,435, right? And it says here in the first sentence, that 30% of those students will go to UTSA. So in my picture, I know that 30% of those students are going to wind up going to UTSA. So that means I need to know what is 30% of 15,435. Right? That's the question. I want to know how many students actually transferred to UTSA, and it's 30% of this group, right? Now, this thing I did in yellow here, I mean, sorry, in blue, this right here, what is 30% of this? That's a problem like we just did, isn't it? That's a problem like the previous problem. So if I set that up as an equation, can someone tell me what that equation would be? What's the equation?
X is equal to 0.3 times 15,435.
15,435. Exactly. So what is our X, right? Is the equals, 30% is the 0.30 of his multiplication, and then the 15,435. Make sense, everyone? I want to know what 30% of the Northwest Vista population was. So I'm going to do that on my calculator. 0.3 times 15,435. Now, my answer is 4,630.5. So it looks like half of a person went to UTSA. It's okay. All right. We'll just leave it as a decimal. This is like an approximation. Okay, y'all with me? We had 15,435 students, 30% of them transfer to UTSA. So that's how many of them are at UTSA. Now, of these transfer students, of those students, right? That's of these students right here that we just found, 12% are going to major in biology. So of this group, I know that 12% of them are going to do biology. And so I want to know what is 12% of that group, 4630.5. And so you can set up another equation. X is 0.12 times 4630.5. Do that on your calculator. And you get 555.66. We almost had triple sixes again. Not quite, not quite. All right, so that's it. That's our answer. Now we can round it. I mean, about approximately 555 students. So of the 15,435 students that are at Northwest Vista, 30% go to UTSA, and of that group, 12% go into biology. So 555 students from Northwest Vista wind up in biology at UTSA. That's what we just figured out. Does that make sense, everyone? That was two of the equations built into one problem. Questions or no? Look at number 9. What is the difference between number 8 and number 9? There is a difference.
Where to find the percentage?
Yeah, so here, do they tell us how many students are at Northwest Vista?
No.
They don't, right? They don't. And so, you know what we did before? We started here at Northwest Vista. We did 30% went to UTSA. And then after that, we said, okay, well, 12% of those people wind up in biology. But here, we don't have a number to start with, do we? We don't. right? We don't have a number to start with. So what we're going to do is we're just going to kind of think about it as, what did we do? What did we actually do when we did this up here? We started with the 15,435. And what did we do with that number on the first step? Multiplied it by 0.3, right? Yes. And got an answer. And then what did we do with this number? Well, we took it and we multiplied it by 0.12. And then that gets us our final answer. So here's what I'm doing. I'm going to call the number of people at Northwest Vista X. When I come over here to UTSA, I have to take 0.30 of that X. That's what 30% of whatever Northwest Vista's population is, X. The number that will transfer to UTSA is 30% of that. So 0.30 times that. And then 12% of that means we're going to take 0.12 and multiply it times the 0.30x. So whatever answers here, we hit it with 0.12. So on your calculator, do 0.12 times 0.3. What I'm saying is multiply those two things together, and you should get 0.036x. What does that tell you? You start off with, the full population. You go here, now you're 30% of the population, and then you go 12% of that, and you wound up with 0.036 of the population. What does this number represent?
Amount of students going into biology.
Exactly. This is how many students are in biology at UTSA, but specifically, what does this number 0.036 tell us? What
The
is
percent
it?
of students from NVC that went to UTSA majoring in biology.
If we convert that to a percentage, it's 3.6%, right? That's what this number is a percentage. What that means is that if we start off with all of our students here at Northwest Vista, if you take 30% of those students and then 12% of those students, you wind up getting 3.6% of the original group. 3.6% of those students wound up over there in biology. And that answers the question. The question was, what was the percentage of NVC students that wind up at UTSA in biology? So there's a big difference between these two problems. In the first problem, they give you the actual population, right? They give you the actual population. And so you can find an actual population, a number for the, a number that represents how many students are there at UTSA. But if you don't give a number and just tell me the percentages, then you can tell me what the final percent is at the end. And all you're doing is multiplying these two percentages together. Okay. Let me give you another example of this. This was something that actually happened to me a few years ago. So I went to Lowe's, all right? I went to Lowe's, and my wife and I decided to buy a washer and dryer set. Okay, we need a new washer and dryer, all right? And I don't remember how much they were. All right, so I'm just going to make up a number because I don't know how much washer and dryers are, but I'm just going to say, what do y'all want to do? How much do you think? They're not like the cheapest ones we could find. They weren't the most expensive, so I don't know.
1,500.
1,500 for the set. Okay, so it's $1,500 bucks. There we go. All right, for my washer and dryer. Now, I actually had two things in that I could do. I had one, they were running a special, all right? One special was 20% off. And the other special was I could get a 10% discount and then another 10% discount. So I think I was gonna have my dad do it because he's he's a veteran, so he gets 10% off. And then he had a 10% off coupon. So they were gonna give the 10% for him and then the 10% for the coupon. And then I had the 20% off coupon. So which one do I do? Or does it matter? What do you think? Does it not matter? Does it matter? Is it the same thing?
I would say it's the same thing, but I feel like I'm wrong.
Yeah, I wouldn't be asking, right? If it were. So let's look at it, okay? So what does 20% off mean? 20% off means, let's see how much is the discount. The discount, well, what we need to do is we need to figure out, what is 20% of the 1,500, right? So I can just set up an equation real quick. X equals 0.20 1,500. And if you do that, you should get 300. So that's not how much it costs. That's the discount, okay? I will save 300 if I do it this way, okay? Now, the other way is tricky because the way they do it is when they ring it up, they take the 10% off. They scan the coupon and they take 10% off, and then they put in the code for the veteran and they take another 10% off. So they do 10% twice. Let's see if we do it that way, if we get the same answer. So first, let's do the first 10% off first. All right. So if we do that, we want to know what is 10% of 1,500, right? That's what we're going to do first. So this means X is 0.10 times 1,500, which gives you 150. Okay, that's how much I've saved so far. Right, I saved 150. Okay, now they're going to scan the second 10% off. So now I want to know what is 10% of what? Of what? It's not 1,500 because they scan the first coupon, right? And when they scan the first coupon, how much did they take off?
150.
150. So what's left to discount?
13.
Well, we have to take 150 away from this, right? So if you subtract 150 from that, they're only taking 10% off of 1,350 because that's how much remains. Does that make sense? It's tricky, but it's not the same thing. So we go X is equal to 0.10 times 1,350. And if you do that, you get X is equal to 135. So I'm going to save that now. So how much have I saved total over here? They took off 150 and then 135. That's only what?
285.
285.
85.
Right? That's my total savings. And over here it was 300. So what do you think I did? I had my dad pay for it. That way I didn't have to pay for it. No, I'm kidding. I did the 20%, right? Because it just makes more sense. Now it's only $15 difference, but it's $15, right? I mean, it's 15 bucks. So that's a common misconception that something like a 20% coupon is equivalent to two 10% coupons. It's not the same. It's better if you have the 20% taken off all at the same time rather than 10 twice. Now, what was interesting about that was that the person checking us out was trying to convince me it didn't matter. They're like, it doesn't matter, 10 and 10 and or just the 20, you can do it either way. I'm like, you can't do it either way. And they just refused to believe me, but that's why I just explained. Obviously I didn't go through this explanation for them, but okay, we are gonna, what time is it? Where were they? There we go. All right. In a Gallup poll of 976 adults, 68 said they drink alcohol every day. What is the percentage of respondents who said they drink every day? This is not a trick question. This problem is actually much easier than the previous two. So what do y'all think? How do we set this up? What are we trying to do here?
My first thought is to put 68 over the 976 and then multiply it by x over 100.
So you are setting up a ratio, right? The ratio you're setting up is the ratio of drinkers over the people who were surveyed, right? And
Yeah.
if you do this, you're going to get a decimal. 68 divided by 976. So you get an answer. It's approximately 0.0696, almost a 666 again. Let me round that last one up to a 7. There we go. This is the ratio of drinkers to the number of people who were surveyed. And we want to know what percentage of the respondents said they drank every day. That would be basically saying, rewrite this ratio as a percentage out of 100. So we take this decimal, move the decimal point 2 places to the right, and we get about 6.97%. Almost 7% of the people in the survey said that they drink every day.
Could you,
Go ahead.
oh, I was just gonna say, could you set it up as something like X equals the percent of, so X times 976 has to equal 68?
Yeah, see, this is a problem. So yeah, if you try and turn this one into an equation, this is where things get tricky. If you do what is, and then you're saying percent. So tell me again how you wanted me to write this, or I'll let you say. Could you have done what?
I don't even know if that's possible. Could you do X times 976 equals 68?
X times 976 equals 68. Yes, that would work.
Because that's the percent, we want to know the percentage of, which would be time, that amount of people, and that has to equal 68 people.
Yes, you could do it that way. I would just say it works. I would just say that in this problem, it's not as clean as these, right? These are very straightforward. So on your exam, when I tell you to write each equation, write each of the following as equations and solve, this is the game we're playing. If I give you word problems like this and I don't tell you write the equation, then you can figure these out however you want to. Just realize that, yes, sometimes you can convert the statements into equations. Sometimes it might be a little harder to do. I don't know, Emily, is that okay?
Yes.
Okay. Yeah, so if you solve this equation, you get the same answer. Just remember to convert it to a percentage at the end. Okay, let me see where we are here. All right, yeah. So we have a formula. Okay, we have this form. We have 2 formulas that we need to establish now that will help us solve the next problems. The first formula or first equation is this one. This is how you figure out, this is a formula that tells you the total amount that you would pay for something if you know its price and you know the tax rate. So we all know when you go buy something at the store, most items you have to pay tax on. Some things you don't have to pay tax on, certain food items and stuff. But You know, you pay tax if you go buy a new calculator, right? So the way you determine the price or the total is to take the price, the sticker price, right? And then you add to it the price times the tax rate. Now the tax rate is going to be a percentage, but this must be a decimal in the formula. Okay, it must be a decimal when you write it in here. Tax rates, when they're given to you though, they're given to you as a percentage. So when you stick it into this formula, make sure you just move that decimal over and get rid of the percent. Do y'all know what the tax rate is in San Antonio? No?
Is
Like
it is
sales
it
tax?
like 8.25?
Yeah, I don't
something like
actually
that?
remember exactly what it is. We can look it up. I'm pretty sure we can find it. Let me see, tax rate, San, you know, all you'd have to do is pull out a receipt. It should be on there, but yeah, it's saying it's 8.25. It's saying it's 8.25. Now, let's try a different city.
I know for like Charleston, it was about the same.
Let's do San Francisco. We'll try Austin in a second. Let's try San Francisco. Oh, okay. Well, I'm seeing here California, 8.625.
You might try a state that has income tax, because sometimes their
Ooh.
sales tax can be lower if they have income tax. They
Yeah.
won't charge as much.
Let's try
Oh.
New York.
Yeah, like, okay, so what you're referring to is if they have a state income tax, right? Because
Right,
we all pay federal income tax, but some
Right.
states have an additional state income
They
tax,
start, yeah.
Right. And
but
if
then their
they,
sales taxes are usually lower.
that's
that's
why
what you're
ours is higher, because Texas
Right.
doesn't have an income tax, but it's another state that does have an income tax will most likely have lower sales tax.
Yeah,
I
state,
believe South Carolina has a state income tax.
with income tax. Let me see, states with income tax.
Louisiana too.
Louisiana. So let's look at the tax rates in, let's see, Louisiana, or let's see, what else is on here? Okay. So let's go with sales tax, Louisiana, right? 4.45. Oops, sorry. So you might be like, let's go move to Louisiana. They have a lower sales tax. They make up for it because they have an income tax at the end of the year. Yeah, taxes are weird, right? Taxes are weird. It's, you know, they're gonna get you no matter what. They're getting you. They're getting your money. So in San Antonio, the tax rate is 8.25. Right? That's what it is. So depending on, and for most practical purposes for you buying something here, we're gonna, you know, we would have 8.25, but in the word problems, it'll state it for you. Okay. So you take the price, you add to it the price times the tax rate, that's the total you pay. Now, the next formula that we'll need is this, the way that you can figure out the percentage increase or the percentage decrease of something. This is a very useful formula, all right? Because it's a simple formula. Most people don't know it though. Like if you go, let's say, I just went out earlier this morning to go grab some stuff from the grocery store, and the gas was $2.79 a gallon. And I filled up last week for $2.89. I know that for a fact. That's what I paid last week. All right. So if I want to know what percentage it went down, okay, if I want to know the decrease, then here's the formula. What you do is you take the new price, which would be this, you subtract the old price, which would be this, and you divide that whole thing by the old price. Whatever you get here, multiply it by 100, and that's your percentage. Okay, so let me do it for this one. I'm just since we're almost out of time, let me do it for this one. If I wanted to know how much the gas prices decreased since last week, I would take the new price, subtract the old price, divide by the old price, not the new price, the old price. And so in the numerator, I, subtract this. This one is what? Difference of 10 cents. So it's negative, be careful, it's negative 0.10 over 2.89. So divide that by 2.89 and I get negative 0.0346. Convert that to a percentage by multiplying by 100. That's this multiplying by 100 right there is really what moves the decimal point 2 places over. So if you multiply that by 100, you should get negative 3.46%. The negative tells you that it decreased, the price went down. If it were a positive answer, that tells you the price went up. And so it's about a 3% decrease in the price of gas. Next week, it'll probably go up 8%, but gas prices fluctuate. All right, it's 10:40. Why don't you just try number 14? This problem, I told you, I don't write these problems. This came out of the packet. I don't know. Amy bought a pool hall, as if buying a pool hall is something people do every day, right? I guess that's a place where people pay pool. So it's a bar. I don't know. She paid $219,765 for this pool hall. All right. This price you know what? This price includes the sales tax or the 5% tax. What was the price? Okay, let's try it. Let's try this. Let's try this. So this price includes the 5% sales tax. So this right here is our tax rate. Now, as a decimal, it's 0.05, right? Just keep that in mind. That's the tax rate. We're asking for the price of the pool hall before tax. So I'm going to take this formula right here. I'm going to write it a different way. I'm going to write, instead of price, I'm going to put P plus, and instead of writing price times tax rate, I'm going to do P times R equals T for total. Do y'all see how that's this formula? Price plus price times tax rate I'm calling R, is equal to the total. Y'all agree with that equation here? Or understand that equation? What do we have in this problem? What are we given? What is the 219,765?
The total.
The total, that's T. That's not the price she paid, that's the total she paid. And then this is the R, right? We know the R. Which means we can rewrite this as P plus P times 0.05 equals 219,765. Which I'm going to write another way, P plus, when I multiply these two together, I'm going to change the order. I'm going to put 0.05P equals 219,765. I'm trying to find out what P is, right? I want to know what the price is. So I'm going to add these two together. And think about how you add these. This is a 1 in front of this P, and I'm adding a 0.05 in front of this P. So it's kind of like if you're adding 2x and 3x together, that's 5x, right? You add the coefficients. That's the same thing I'm going to do here. I'm going to add the 1 and the 0.05 together. P equals, and then 219,765. Any questions on that step? No? What would my last step be?
Divide.
Divide by 1.05. So you get P is equal to, so I need my calculator, 219, 765 divided by 1.05. We should get $209,300. Okay, we'll do more. I need to tell you what to do for homework, but I need to go look at the packet and pick the problems. So check your email later. I'll do it in the next hour. I'll send you an email showing you what exactly to do out of the packet. Some random information for you, because I know everyone is like at different points in their life in terms of, you know, whether or not you live on your own or you have a family or whatever. This is just kind of some random information for you. If you go buy a car, okay, let's say you go and you want to go buy a car. So if you have a trade-in, right? So let's say you already own a car and it's old and you want to trade it in. Here's your old beater, okay? There's your car, you're going to trade this in. Here's your new car, right? New truck, whatever, okay, new car. Whatever this new car is, whatever the price is, let's say it's, I don't know, $35,000 car, right? Let's just say, you got to pay tax on this, right? You got to pay tax on that car, which can actually be a lot of tax. The way it works is that when you trade this car in, okay, let's say they look at your car, they're like, hey, you know what, we'll give you $10,000 for that car. They said, we'll give you $10,000 for this car. Then what happens is that your tax is not on that amount. It's on the 35,000, take away the 10,000, that's 25,000. You only have to pay tax on 25,000. You don't have to pay tax on the full 35. So it's something good if you sometimes people will want to go sell their cars to, you know, they don't want to trade them in. They'll go try and sell them to someone on, like, you know, person-to-person sale. And, you know, maybe if you sell it to someone, you can get 10,500 for it. Maybe, I don't know. Well, that's only worth it. That's only worth it because here you'd make $500 more, right? This would be $500 more if you sell it this way. But now you got to pay tax on 35,000. And so is tax on 35,000 more than 500? Did you gain or lose? Does that make sense? Like you don't have to do this. I'm just saying, if you want to pay attention and money matters to you, these are little subtleties. You know, the way tax works with cars, it's usually a really good idea to have a trade-in because it brings your tax down on this car. Okay, let's everyone have a great weekend. Look for
Your
your email
tax
for
would
the
be
homework.
$2,000, I think.
What's that?
I think your tax would be over $2,000.
Yeah, well, the
Not
thing is,
worth it.
the thing is though, on $10,000, I believe for cars the tax rate is not 8.25%.
Oh, true. That would
It's
make
lower.
sense.
It's lower on a car. It's not quite 8.25%. I think it's around 6%. So I think this would be, I think you'd still have to pay about $620. I think there's a $620 difference between these. So this wouldn't be enough. You would need to get more than $10,620 this way to make it worth it. Anyway, okay. Y'all have a great weekend, and thank you all for all your patience this past week and week before and everything else. So really looking forward to the break coming up. I hope you are too. Have a good weekend.
Thank
Sorry
you.
about that.
That looks like your old car, Emily. That's funny.
My computer died. That's
What
why I had
happened?
to leave and rejoin.
Oh, okay.
I was wondering if you could scroll up a little bit.
Yeah,
to
yeah.
the last problem.
Yep. Wait a minute. Where did I put it? Yes. You're talking about the one with the price?
Yeah, this
That
one
one
right
right
here. Yeah.
Yeah, I'll leave it there.
Alrighty, thank you.
No problem, John. Have a good weekend.
You too, thank you.